And now going to part B. Part B says that we need to find Z3 minus Z2 in polar form. So let us first find Z3 minus Z2 in the Cartesian form, and then we convert it to the polar form. So what is Z3? Z3 is 4i minus Z2. Z2 has two terms, so we need to open the bracket and say negative 3 plus I. And then we simplify. Here we shall have 4i plus 3 minus I. This gives us here 3i plus 3. So this is the value in Cartesian form of Z3 minus Z2. Now to convert it to the polar form, we need the magnitude and then the argument of this same single complex number. So the magnitude R is given by the square root of x. X is 3 squared plus y. Y is also 3 squared. This gives us a root of 18. 9 plus 9 is 18 units. You can leave your answer in short form in this format, or you can write it in decimal places. So after getting the magnitude of the complex number, now we need to find the argument of that complex number. So the complex number is Z3 minus Z2, that is the imaginary axis. This is the real axis of Z3 minus Z2. This is the origin. When you look at the values, they are the same, 3 and 3. So we are going to mark equidistant from the origin. These are negative 3, 3, negative 3. Since they are both positive, it means our complex number will be in this format. This is the point of intersection of 3 and 3. Draw a straight line from the origin up to where the complex number is. Put the arrow. You can even name that this is my complex number, Z3 minus Z2. Now we need to find the argument so that we can use it to find the modulus argument form. So the argument is this angle that the complex number makes with the positive real axis. Now from here to up here is the same as from 0 to 3. That means this side is 3. From the origin up here is 3. That means this length adjacent is also 3. So how do we find it? Since we have the magnitude of the complex number Z3 minus Z2, as here, you can use either sine, cosine, or tan, so that you find the angle, and they will give the same answers. And because this is the last example, I'm going to use sine, I'm going to use cosine, I'm going to use tan, so that you see that it actually gives the same answer. So let me start with tan that we have been using. So we shall say now tan of angle theta becomes the opposite ray over adjacent is also 3. That means here now theta becomes the tan inverse of 1, which is 45 degrees. This is the argument when we are using tan. What if we are using sine? If we are using sine, we shall say that sine of theta equals to, remember sine is opposite over hypotenuse. And hypotenuse is the length of the complex number, which is root of 18. So let us substitute. What is the opposite to the angle? It is 3 out of the hypotenuse is the length of the complex number. This is the hypotenuse, which we are saying it is root of 18. That means now theta here becomes sine inverse, becomes the sine inverse of 3 out of root of 18. And then you press your calculator and you expect to have the same answer of 45 degrees. So we're going to say shift sine to give us sine inverse, and then you open the bracket and say 3 divided by root of 18, close the bracket, 45. So if we're using sine, it is still giving us also 45 degrees as the value of the argument theta. What if we choose to use cosine? Instead we shall have the same answer. So we shall say cosine of theta becomes, you know that for cosine it is adjacent out of hypotenuse. That means that here cosine theta becomes, what is the adjacent to the angle? It is 3. Out of hypotenuse to the angle is root of 18. That means here theta becomes the cos inverse of 3 out of root of 18. Then you press the calculator. Press shift cosine to give you cosine inverse. Then you open the bracket and say 3 divided by root of 18 and close the bracket. It's giving me 45 degrees. So it doesn't matter whether you're using tan, sine or cosine, as long as we know that for tan it is the ratio of the opposite to the adjacent, sine is the ratio of the opposite to the hypotenuse, cosine is the ratio of adjacent to the hypotenuse. Then you get the inverse and you get the same answers. So after getting the argument in either using tan, sine or cosine, now we need to find in polar form the complex number z3 minus z2. So you just create a small section and say, because we know that from the complex number is given by r cosine of theta plus I sine of theta. That means ours, which is z3 minus z2, now becomes r, or r is root of 18, open the bracket, cosine of the angle 45 degrees plus I sine 45 degrees. That is the polar form of z3 minus z2. Or you can use the alternative. You can use the alternative that says z equals to r comma theta. This now gives us z3 minus z2 equals to r, which is root of 18, comma, and the angle is 45 degrees. So it doesn't matter whether you're using sine, cosine, or tan to get the angle. After getting the angle, which is the argument or the principal argument, then you just come and substitute in the general form of the argument of the complex